Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns simultaneous equations. This guide introduces simultaneous equations and describes a general method to help to solve simple linear simultaneous equations. Introduction. An equation, a piece of mathematics with an equal sign in it, describes a graph. Different types of equations describe different types of graphs. For example, all straight lines have the general equation y equals mx plus c, where m is the gradient of the line and c is the y-intercept. And all parabolas have the general equation y equals ax squared plus bx plus c. See study guides, the straight line and quadratic functions for more details. Other functions have distinctive graphs which you should familiarise yourself with. See fact sheet, 5 basic functions. Another idea in mathematics that you should be comfortable with is the meaning of solving an equation or set of equations. In order to solve a single equation, you need to have one equation and one unknown. For example, you can solve the equation 5x minus 3 equals 0 as there is only one unknown, x, but you cannot solve an equation like y equals 5x minus 3 because there are two unknowns, x and y. If you want to solve equations with two unknowns, you need two equations. So you can solve a pair of equations such as y equals 5x minus 3 and y equals 2x plus 4. These two equations are both in the form y equals mx plus c, so their graphs are straight lines and are known as simultaneous equations. The solution of these types of simultaneous equations is usually a single value of x and a single value of y, which represents a point which occurs on each graph. If a point is on both lines, then the two lines must intersect at that point. Solutions to simultaneous equations are the points of intersection of the lines the equations represent. So, the mathematics of simultaneous equations is the same as that of lines. In fact, the subject of solving simultaneous equations is called linear algebra, the algebra of lines. In this guide you will learn 1. How to find the point of intersection of two straight lines by solving simultaneous equations which are of the form y equals mx plus c. 2. How to tell if two lines are parallel. As parallel lines do not intersect, they give rise to simultaneous equations which have no solutions. Different types of simultaneous equations. When you are trying to solve linear simultaneous equations, it is extremely helpful to express them in the form y equals mx plus c. You may need to transpose your equations to make y the subject. See study guide, Rearranging Equations for help with this. The reason for doing this is that you can identify the gradient and y-intercept of each graph easily, and these values can help you find the solution. 1. Equations with different gradients and different y-intercepts. Example. Examine the simultaneous equations y minus 3 equals 2x and y plus x plus 6 equals 0 and comment on their graphs. The first step towards learning about simultaneous equations is to transpose them for y. So, y minus 3 equals 2x becomes y equals 2x plus 3. Equation 1. Y plus x plus 6 equals 0 becomes y equals minus x minus 6. Equation 2. It is useful to label your equations, in this case 1 and 2, as you can easily refer back to them within your answer. Now you have them in this form, you can see that y is equal to both 2x plus 3 and minus x minus 6. As both of these expressions are equal to y, you can set them equal to each other to give 2x plus 3 equals minus x minus 6, which only has one unknown, x, and so can be solved. A good method for solving an equation like this is to collect all the unknowns on one side and all the constants, the numbers, on the other. So, adding x to each side and then subtracting 3 from each side puts all the unknowns on the left and all the constants on the right. 3x equals minus 9. To finish, divide both sides by 3 to find that x equals minus 3. This is the first part of the solution, the x coordinate. You should realise that a solution to the simultaneous equations of this type comprise two parts, a value for x and a value for y. You need to now find a value for y. Since you have the value for x, you can choose either 1 or 2 and substitute x into the equations to find y. Choosing equation 1, y equals 2x plus 3, which equals 2 multiplied by minus 3 plus 3 when x is equal to minus 3, which equals minus 6 plus 3, which equals minus 3. Choosing equation 2, y equals minus x minus 6, which equals minus 3 minus 6 when x is equal to minus 3, which equals 3 minus 6, which also equals minus 3. It does not matter which equation you choose, each give the value of y as minus 3. It is true that you only need to pick one equation to find the other unknown. However, you can use the other equation to check your answer, as it should give you the same result. The solution, y equals 2x plus 3 and y equals minus x minus 6, is x equals minus 3 and y equals minus 3. This result says that the graphs of these functions cross at the point minus 3 minus 3, as shown to the right. This is the line y equals 2x plus 3, and this is the line y equals minus x minus 6. You can see that they cross at the coordinate minus 3 minus 3. Simultaneous equations with different gradients and y-intercepts are the most common types students are asked to solve. Linear simultaneous equations with different gradients and different y-intercepts always cross at a single point. 2. Equations with different gradients and identical y-intercepts. Example. Examine the simultaneous equations y plus 2x equals 3 and y minus 3 equals 5x and comment on their graphs. Again, to gain insight into the simultaneous equations, you must first transpose them and make y the subject. Y plus 2x equals 3 becomes y equals minus 2x plus 3. Equation 1. Y minus 3 equals 5x becomes y equals 5x plus 3. Equation 2. This shows that the graphs for 1 and 2 have different gradients, minus 2 and 5 respectively, but the same y-intercept of 3. As the y-intercepts are the same, the graphs must cross at this point. See picture to the right. As the solutions to simultaneous equations are points where lines intersect each other, the y-intercept must be a solution. Here, the y-intercept is the coordinate 0, 3, and so the solution is x equals 0 and y equals 3, which can be easily checked by substitution. This is the line y equals 5x plus 3, and this is the line y equals minus 2x plus 3. You can see that they cross at the y-intercept 0, 3. Linear simultaneous equations with different gradients and identical y-intercepts always and only cross at the y-intercept. 3. Equations with identical gradients but different y-intercepts. Example. Examine the simultaneous equations y minus 1 equals 6x and y divided by 2 equals 3x minus 2 and comment on their graphs. Again, to gain insight into the simultaneous equations, you must first transpose them and make y the subject. Y minus 1 equals 6x becomes y equals 6x plus 1. Equation 1. Y divided by 2 equals 3x minus 2 becomes y equals 6x minus 4. Equation 2. The transposition shows that the graphs for 1 and 2 have the same gradient of 6, but different y-intercepts, 1 and 4 respectively. Graphically, these represent parallel lines, as seen to the right. As parallel lines do not intercept, you would expect there to be no solutions to the simultaneous equations. If you set the two expressions for y equal to each other, you find that 6x plus 1 equals 6x minus 4. After subtracting 6x from each side, you get 1 equals minus 4, which cannot be true. As your mathematics leads to a result which cannot be true, you cannot solve 1 and 2. The graphs y equals 6x plus 4 and y equals 6x minus 1 are parallel and so have no solutions. As a solution to a simultaneous equation represents where the graphs cross, it cannot be true that the graphs cross, and so they must be parallel. Linear simultaneous equations with identical gradients and different y-intercepts represent parallel lines and do not cross. 4. Equations with identical gradients and identical y-intercepts. Example. Examine the simultaneous equations 3y plus 9 equals 12x and y minus 1 divided by 4 equals x minus 1 and comment on their graphs. Again, to gain insight into the simultaneous equations, you must first transpose them and make y the subject. 3y plus 9 equals 12 becomes y equals 4x minus 3. Equation 1. Y minus 1 all divided by 4 equals x minus 1 becomes y equals 4x minus 3. Equation 2. This shows that 1 and 2 are identical, and so they have the same gradient of 4 and a y-intercept of minus 3. Setting the two expressions for y equal to each other, you get 4x minus 3 equals 4x minus 3, which is always true. This implies that there are an infinite number of solutions to 1 and 2, as there are an infinite number of points which occur on both lines. Linear simultaneous equations with identical gradients and identical y-intercepts are the same line and have infinite solutions. Generalization. If you have two linear equations, you can always write them as y equals mx plus c, equation 1, and y equals nx plus d, equation 2, where equation 1 has a gradient of m and an intercept of c, and equation 2 has a gradient of n and a y-intercept of d. You need to transpose your equations to make y the subject before you decide the values of m, n, c and d. As shown in the examples above, knowing m, n, c and d can help you understand the simultaneous equations, as illustrated in the following table. When the gradient m does not equal n, and the y-intercept c does not equal d, this is type 1. The lines cross at a single point, not on the y-axis. If the gradient m does not equal n, but the y-intercept c is equal to the y-intercept d, this is type 2. The lines cross at the y-intercept, 0c, which is equal to 0d. If the gradient m equals n, but the y-intercept c does not equal d, this is type 3. The lines are parallel, and so you get no solutions. If the gradient m is equal to n, and the y-intercept c equals the y-intercept d, this is type 4. The lines are identical, and so you get infinite solutions. When straight lines cross, in types 1 and 2, they only cross at a single point with the coordinate x, y. When you solve simultaneous equations, you find the relevant values of x and y, and hence you can find the coordinate. Given the two equations, y equals mx plus c and y equals nx plus d, where the lines cross, the value of y is the same for both equations. You can write this another way by equating the right hand sides of the equations as they are both equal to y. mx plus c equals nx plus d. When m equals n and c equals d, you find the equations above become mx plus c equals mx plus c, which is always true and so has infinite solutions. When this is not the case, the advantage of writing mx plus c equals nx plus d is that you now only have one variable, x, and so you can transpose this equation to find it. This gives a general solution for x of x equals d minus c divided by m minus n. Call this equation 3. Substituting the values of c, d, m and m into equation 3 gives the x coordinate of the intersection point. You can also use this equation to find the value of y by choosing either y equals mx plus c or y equals nx plus d and substituting in for x. You find that y equals d multiplied by m minus c multiplied by n, all divided by m minus n. This is equation 4. You can use equations 3 and 4 to help you analyse all the different types of simultaneous equations. When m does not equal n and c equals d, equation 3 gives x equals 0 and 4 gives y equals c equals d, which means that the lines cross at the y-intercept. When m equals n and c does not equal d, equations 3 and 4 involve dividing by 0 and so cannot work, indicating parallel lines. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.